Okay, that'll go away. Okay, so relation, I think it goes, there we go. All right, so relation is just when you have like two things that they don't even have to go together, right? So we just say we have a bunch of ordered pairs and they are related, right? So it could be like we have like the number of shoes compared to the number of glasses, right? Like they don't really go together, but we could make a comparison, right? Or if I'm in my kitchen, I could compare the number of knives to the number of bananas. Like, like you wouldn't normally like put them together, but a relation doesn't have to go together. It's just here are two things, what are their values, right? So when we write a relation, we typically write it as ordered pairs, and we're just listing out the numbers. Okay, so we have 4 different ways that we can represent a relation. We have the good old table. We have mapping. On mapping, I left off the little arrows. So what you'll see in a mapping is these are all your x values, these are all your y values, and then the arrows are going to match the numbers up. So if we took this number -5, we could match it over here to the 0, and we just draw an arrow. So that ordered pair would be -5, 0, right? Or maybe we take that -5 and we match it with the -3 as well, and that would be a second point, -5, -3, right? And then we could say maybe the -2 goes with that one, maybe the 1 goes with the 0, whatever. Like it's just sort of this hodgepodge of arrows of things that go together. Okay. And again, they just make ordered pairs. Then we have our graph. We have our ordered pairs on the little dots with our x-axis and our y-axis, just like we've done forever. And then we have an equation, right? So all of these methods, you need to be able to tell what the domain and range are from them, okay? All right, so everybody remember domain is x, range is y? Okay, so when we're looking at the domain, we're going to go from left to right, which is pretty easy for us. It's sort of the way our eye naturally goes across the page, right? Like we're reading a book, left to right. So we always list the smallest value in the domain first, and we always work our way to the biggest value, okay? When we're talking about the range, this is where people sort of get mixed up sometimes because our like, I don't know, maybe it's because we're positive beings and like we go to the top first, like we want everything to be high first, and then we work our way down, which is backwards for range. We always want little to big. So if we're going up and down, the small values are always down at the bottom first. So when we're looking at the range, we want to start at the bottom of our graph, and we're going to work our way up to the top. Okay? Yesterday, I made the inappropriate comment. They're like, Ms., don't ever say that again. But I have to say it to you because I think it's going to make you remember it, okay? So, when you first, pretend you're an older person, like my age, right? And you're like, you meet, you see, a really fine-looking person, right? Really handsome, really beautiful, really whatever to you, right? Okay? And you're going to totally check them out. You're going to start at their toes. And you're going to work all the way up to the top. And yesterday, they're like, no, miss, you look at their eyes first. Wrong. Wrong. Okay? Because the phrase is you're going to look somebody up and down, right? That's the phrase. So you're going to check them out up and down. So you're going to start at the bottom. You're going to work all the way up. Hey, go back up. If you need a second look or whatever. Okay, but again, it's just totally stupid. But the idea is you'd be like, oh, yeah, she said start, check them out. Look at the bottom. Like, whatever, okay? I know if my children were here, they'd be like, Mom, don't ever say that again. But you're allowed to say that too. But we'll see if it helps you remember, okay? Always start at the bottom and work your way up. Okay, so with our ordered pairs, the little dots, and the mapping, all we're going to do is list the numbers, right? Okay, but again, we have to list the numbers in order from little to big, okay? So we're going to list numbers, small to large. And the other thing is don't repeat. So if it has 2 of the same number, you don't write it twice. You just write it one time. Okay. All right, so I'm going to use domain as blue. So I'm going to highlight all of my X values for the domain. And then I'm just going to list those in order from little to big. So they're already highlighted, they're already colored, or you can write them out and then sort of like rewrite them if you wanted to put them like in here maybe. Like the numbers are -1, 7, 3, and -5, right? That's our domain. But we got to rearrange them. So which one is going to be the smallest? -5. So maybe cross that one out, like I already wrote that one. Then the next number would be -1, cross that one out, and then 3 and then 7. And then you put these little squiggly things around it, which has some sort of technical term, but I don't know what they are. A brace, maybe? No, I don't know. I don't know what it's called. Okay, little to big. Yeah? Okay, then we do the same thing for the range. The range are the Y values. I'm going to put X here. Good morning. So the Y values are these 4 numbers here. So if I were to write those out, sort of in here, -1, 4, 0, -1. Which one's the smallest? -1. So I'm going to cross out both of the -1s because I don't want to write it a second time. And then the next number, bigger, 0, and then the 4. Great. Squiggle, squiggle. Okay. Does anybody need a quick art lesson on how to draw the little squiggly? Literally, you could just go like, oh, that's fine. So technically, it's like an S, and then a backwards S, and then on the other side, it starts backwards, and then goes forward. Yeah. So it like has this little sort of like pinch sort of in the middle, and then curves it. But whatever, it doesn't really matter. Okay. Number 2 with the graph, you have a couple options here. Depending on how your comfort level with dealing with ordered pairs on a graph. If you wanted, you could just simply like name each of the ordered pairs. Like this point right here, here's our origin. So this would be 1 to the right and down 3. So +1, -3. And then once you have them written out, you're essentially doing the same thing that we just did when we had the numbers, right? Okay. Your other option, if you don't want to do that and you're like, I'm really solid, I'm really good with graphs, okay, your option would be to just start at whichever side you need to for your domain. So where would we start on the domain? We're going to start at the left. So I'm going to start over here, right? This is my starting point. And I'm going to work my way to the right, and I'm just going to stop whenever I come to a point, right? So if I start here and I come this way, the first point is right here, which is way down here, right? So what number is this? These are all my x's. What number is this on my x-axis? -3. This is 0, 1, 2, 3. So -3 is my first x value. So essentially I take that point and I just pull it up to the x-axis and find the number. Okay, and then you do the same thing. So keep going. So now we did that point. Now we're going to keep going. The next point is right here, but it's way up at the top. So what number is this? -1. And then we keep going. There's nothing at 0. Is there something here at +1? Yeah, there are 2 of them. I don't care that there are 2 of them. I just, like I have a range value or a domain value of 1. And then there's 1 at 2 as well. Okay, so again, if that's like too confusing for you, and you're like, I'd rather just see the numbers and you're really good with writing your ordered pairs, then you can just write them down that way. Okay. All right, so can we go from the bottom up for the range? Start with them toes, you know, toes are sexy. I'm sorry, I had to say it. God gave us toes so nobody could say they're perfect. Okay, and I will put that on record saying that. Okay, come to terms with your toes. God gave them to you for a reason. It's okay. Everybody has ugly toes. No, I got beautiful toes. No, you don't. No, you don't. Okay, so this is our y-axis. So we're going to start way down here at the bottom, and we're going to work our way up, right? So the very first point we come to down here is this one way over here. So bring that over to the y-axis. So what number is that? That's how many down? Down 4. And then we're going to go up to the next one. There's one right there. So the thing with this is sometimes you like miss a point, right? Because they're kind of tiny. So there's one at -3. Where's the next one? Here on the axis. So that's at 0. And then the next one is up here at 2, and then 3, 4, 5, 2, 5. Okay. All right, and the last one with mapping is extra easy because unless on mapping, unless they put like an extra number in there, which they don't usually do, like notice that every single number has an arrow, what does that say? Has an arrow going to it or coming away from it. So we're literally just like, it should already be in order. Like I've never seen mapping intentionally out of order unless they were being like really ugly, and I don't know why we would do that. Okay, so literally we just run down the list. -2, -1, 0, 1, 2. Like you shouldn't really have to do any work for that. They should already be done for you. Okay. All right, so that's the super easy part. Then it gets a little bit more challenging with our graphs, okay? And for today, our graphs are already going to have pictures for us. Sometimes they'll give us the equation and we need to type it in and look at the graph. We'll do that in another day or two, okay? All right, so numbers 4, 5, and 6, it says give the domain and range of each relation in set notation. So set notation is the one with the inequalities, greater than, less than, right? Equal to, and all of those things. Okay, so the deal is that if you have a solid line, like at the edge of your graph, then that means that that value is included, right? A solid line means there could be a dot there or a point. And so that's going to be a greater or equal to or less or equal to, okay? If there is a skip or a jump in your graph or a hole, okay, which is just going to be like a little open dot in the middle of your graph, that's going to be one of these where you don't have the equal to part, right? Okay. So let's do domain first. Okay, so what I need you to, there are a couple, I have lots and lots of different ways to explain domain. So if what I say right now doesn't work for you, when you get to your assignment, then be like, can you explain it a different way? Like I didn't get it, right? I got lots of them in my pocket. This is the one that tends to work for the most people. Okay, so on domain and range, we're going from left to right. So the idea is this is the far left, this is the far right. So if we were to essentially like box in the graph, right? Where would those edges touch the graph? And it would be right here. Like if I drew a vertical line right there and a vertical line like right there. That would be the edges or the border for the graph. Yeah? Okay, so the question then is, there are two things. One is, what touches that line that we just drew in? Sometimes it's an arrow, sometimes it's a dot, right? And the second question is, in between those two lines, is our line solid? Like, is it consistent or continuous? Or does it have like a break or a stop in it, right? So that it gives us like two separate parts, something, okay? So what do we see here on the edge of this graph? When we draw this line down here on the left, what is it touching? It's touching this thing right here. What is that? That's an arrow, yep. Which means what? It keeps going forever and ever. So the thing with domain is, this arrow looks like it's pointing down, right? But down is the range, right? Up, down is range. So this, when I'm talking about domain, I'm talking left to right. So even though this looks like it's going down, it's still going to be going out to the left a little bit, right? Like as it goes down, it's still going out to the left a little bit more. And as it goes more and more and more to the left, forever and ever and ever, what's it eventually going to get to? Forever and ever. What number's forever and ever to the left? negative infinity. Like forever, ever. Like, what? Oh, who said thumbs down? That's sad. Is that what you said? You said it, thumbs down? That's why I was like, no, that's negative infinity. You know that. Oh, well. The ghost in my computer is unhappy with our lesson. Get over it. It will be okay. All right. So then the line goes forever and ever, right? It never stops until over here there's another arrow, which means it's going to keep going forever and ever, right? So in Algebra 2, when you saw a graph that looked like this, you're like, duh, it goes forever and ever from left to right, right? So do you see that this domain is the same as this? The lines just turn differently, right? It has some squiggles, it has some other things to it, but essentially the line keeps going forever and ever from side to side, right? So this domain is all real numbers, forever and ever. Okay, and then we switch to the range, talking about going up and down. Does our graph, the first question you can always ask yourself is, does it go forever and ever up and forever and ever down? Or does it stop at some point? Use your words. Does it stop at some point?
No.
So you have arrows on the top and arrows on the bottom. I don't have any arrows on the top. Yeah, there are no arrows up there. All arrows are going down. So down here at the bottom of my graph, if I were to sort of box this in, the bottom of my graph is down here with those arrows. But the top of my graph, it stops like right here. Sort of looks like the cowboy hat, Big Tex cowboy hat. So the question is, what are those values? So where do we start? Down at the bottom. So down at the bottom down here we have arrows. So those arrows are pointing towards negative infinity, forever. And then at the top we have no arrows, so we need to know what number that is. Okay, so find the very, very top part and trace that over to your y-axis and count up to whatever that number is.
The part in the middle, like 2 peaks?
Yep. No. Yeah, like at the very top though. In the top between the 2 peaks. Yeah. So here's 0, 1, 2, 3, 4, 5, 6. Yeah. So if I were to just sort of put this into like normal person terms, my graph is below 6, right? Like it never goes higher than 6. So how do I write that as an inequality?
Oh, x is
Less than 6. Could it be equal to 6? Is it a solid? Could I put a dot there on that line? Yes. Okay, but instead of x, because this is range, we're going to use y. So domain is always x whatever, range is always y whatever. Okay, so all of our values are below 6. It'll never go up above that. Okay. All right, on number 6, this is a square root function. It's like half of a parabola. Okay, so it has this dot and then it has this one curve going up. Okay, my suggestion to you when you have a single dot like this is just to name that ordered pair so that we have a point of reference. Okay, this dot is obviously going to be part of our domain and range. So what is the name of this ordered pair?
-4.
Wrong way. Side first. It's 3 to the side and 4 down?
Yeah.
Or did you count 4 to the side?
I counted 4 to the side.
So remember when you put your pencil down at the origin, that's 0. And then 1, 2, 3. -3 and then down 1, 2, 3, 4. So which value, domain or range, do you think the -3 is going to go with? Domain, because it's in the x spot, right? And the range is going to have something to do with the -4, okay? The only time that doesn't work is if you have something like this, where it has this point sort of, but like everything goes off of it, right? It sort of goes in all directions from there. So it might not be, like this is very obviously an end point, so it's going to be crucial to that. Okay. All right, so again, let's do the domain. Domain was blue. So domain is our x values. So it's this x-axis, right? So I'm going to come along the x-axis until I first hit my graph. So there's nothing way over here. So the first spot where I hit something is right here. That would be the far left of our graph. And then it goes over here, beep, 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 and then we have the far edge over here on the right. Okay, so find this value. That is a dot. So I'm just going to write whatever that number is. So what was that value? That was the -3. So it's going to start at -3, and then it's going to go forever and ever this way, right? With an arrow, there's an arrow on that end. So is that numbers that are bigger than -3 or smaller than -3? Bigger. So greater than -3. Could it be equal? Is it closed or a solid line? Yep. And then domain is X or Y? X. Yep. Okay, the other thing that I talked about yesterday is another way that you can sort of think about domain is, have you seen those like those car crushers, right? Like they take an object and it like squishes it like as flat as it can be, right? So the idea here is that when we're talking about domain, we want to push our entire graph, no matter what it does around the graph, we want to push it to that x-axis. So can you kind of visualize, can you imagine if I took this graph and I sort of went like this and I squished it and I pushed everything right to that x-axis? That's really what we're doing, is we're taking this dot down here and we're pushing it up to the x-axis, bringing this line up, 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 bringing the arrow up. And then we have this line that I drew here in green that is like, that was our warm-up, right? Like it's all on a number line. This is -3. It's a filled in dot. Everything goes to the right, right? That's sort of the concept of what domain and range is. We're just pushing all of those x values or y values to the axis and then naming whatever that is, okay? So if that helps, I don't know. Sometimes that gets, maybe that's where like I blew their mind yesterday. I don't know. All right, so what about our range values? So on range, we're going to start at the bottom and we're going to work our way up. So down here at the bottom, if I put my pen way down here at the very bottom, there's nothing down here until I hit this dot right here. So if I were to draw a line in the bottom of this graph, it would go right through that dot that's there. And what number does that dot head over to? -4. So we're going to start at -4, and then which way does our function go from there? Up. It goes up, and the top of our graph is sort of right here because it sort of hits off the edge, but the end of our graph is still that arrow, so it's going to keep going up, 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 up forever, which means it's going to keep getting greater. Is it going to be equal or not? Yeah, equal because it's open. Okay. Everybody right? For real? Okay. All right. So number 6 is like the most complex graph that we're probably going to see for now as we're doing domain and range. Okay. So this is called the reciprocal function, where it's 1 over x. Okay. And the thing about this function is that it has 2 separate parts to it, right? So I have to write the domain for this part, and then I have to write the domain for this part, okay? Because they're not connected, right? If I were to trace this, I was tracing along, and it goes like forever and ever down off the end of my graph. And then I have to pick my pen up and come way back up to the top here and then sort of start over. Okay, so right here in between these 2 curves on whatever this value is, there is a asymptote or a hidden like barrier where it doesn't ever touch that, okay? So what's going to happen is my x values start way over here at -infinity. Yeah, they start way over here, arrow, forever and ever. Okay, and they come all the way up to whatever this number is. Is this 3? Okay, but what I need you to visualize, y'all look, is this line right here. Do you see how it's like flattening out? It's gonna like lay right up beside that positive 3, but never ever touch it. So it's gonna get as close as it can physically get without actually touching the number 3. Okay, so the way we write that is we say our x values are less than 3. Like can't equal 3, anything less than it, right? Or then we skip over to this other part and we pick up again. We're picking up on the other side of 3, and we can keep going, and our numbers keep going and getting bigger to positive infinity, right? So they're getting bigger. X is bigger than 3. So x could be less than 3, or x could be greater than 3. Okay, now you are more than welcome to write your answer like that, or if you want to be fancy, you could say this is essentially every single number, right? Except 3. So you could write it like this. You could say all real numbers where x does not equal 3. If you think that's easier. Like it's really everything except this one number, right? Or you can write it this way with the 2 separate graphs. I don't care. Okay. And then coming up is the same thing. So we still have these 2 separate parts. So the top and the bottom of my graph are still negative infinity and positive infinity. But right here in the middle, there's another break, right? So what is this value where there is a break? Right through the middle there. Where does that hit the y-axis? At 0? Yep. Okay, so here's the other thing. If you wanted to, do you see these two dotted lines? They cross right here at this ordered pair, which is 3, 0. The 3 goes with your domain, the 0 goes with your range, right? Where those two sort of intersect or cross. So again, you could say y is less than 0 or y is greater than 0. Or if you wanted to say the other way, you could say this is all numbers from top to bottom except y can't be 0. Right? So whichever, again, of those you prefer. I know, free choice is rough sometimes. Okay. All right, so the other ones are looking at interval notation. Personally, I like interval notation better. I just sort of feel like domain lends itself to that. But some of these are kind of funky, so let's look at a few more, and then we'll do our last little bit. Okay, so you're going to have to read the directions, give the domain and range in interval notation. So on today's assignment, it specifies put it in set notation or put it in interval notation. Later on down the line, you can do whatever you want. Right? Okay, so let's pick one. How about we start with 7, because it's a little different. We haven't really done a squiggly. Okay, in Algebra 2, we don't talk about this kind of function. Do you remember in geometry when we talked about sine, cosine, tangent? When we were doing like right triangles? So there are functions for all of those as well. So this is actually the sine function, which is sort of like your, it oscillates. It goes up and down, up and down, up and down, and up and down forever and ever. And it's your sound wave, right? Have you seen a picture of a sound wave? Right? So up and down, that's what the sine and the cosine curve deal with those. Okay? So when we're talking about our domain, we're looking from left to right. So the very far edge of my graph, the first thing I see is way over here. It hits the edge of the graph. And what's there? I know they're kind of hard to see, but there's a little arrow there, right? Doesn't mean it keeps going down forever. It's going to keep oscillating. So it's going to go back up and then back down and then back up and then back down. Okay? And then on the other side, the far edge of our graph has another arrow over there. So it's going to keep going up, down, up, down, up, down. Are there any breaks in the middle of that? No. Say no. So this is going to go forever and ever. So we don't write all real numbers. When we're doing interval notation, we say it's going to go from negative infinity to positive infinity. Sorry. Okay. What about up, down? Does it go up, down forever, ever? Nope. Where is the minimum, the lowest part of our graph? Whatever this is right here. So trace that number over to the y-axis and then count down from 0. 1, 2, 3, 4. Is that -5?
Yep.
So it's going to start at -5 and it's going to go up to, where's the top of our graph? Probably the same number. Usually the sign, has a bit of symmetry to it, right? So if it goes down 5, it probably goes up 5. Does it go to 5? Yep. Okay, so the only question now would be, are we going to put brackets or parentheses on this? Okay, so does it actually touch 5?
No.
Like, does the graph go there, or does it just like skim up to the edge of it? If you can't tell, it touches it. It does. Okay, because like if I remember in like our parabolas, we would put a dot like where the vertex was. Like there's a point there, and so that point is a bracket, or it's a solid colored in value. Okay, so it's going to include those points. Okay, if they don't want you to include those points, they're either going to use a dotted line or they're going to use an open circle, sort of like this one. Like this is everything along this line except for this one point right there. Okay. All right, so let's do that one. Can somebody tell me the name of that ordered pair right there where that dot is? -1, -3? Cool. So guess what numbers we're going to use in our domain and range? -1 and -3. Cool. Okay, so when I look from side to side, from left to right, this line has arrows on it, which implies that it goes forever and ever, right? So it goes forever and ever, except at this one number, which is -1. So it's every number, all real numbers, except -1. Okay, so when we write it this way in interval notation, there's not really a shortcut. So we start with, we're going to go from -infinity to -1. Can it include -1? It's an open circle. It's not filled in. So there's a break there. Or we jump to the other side of that dot, and then we pick up again at -1 and we go to forever. Okay. So if I have free choice of how I were to write that, I would write it like we did on the other page. Like I would write it like this: all real numbers, x can't be -1. To me, that's like simpler than this format. Okay, but we don't have a choice right now, so we got to be able to do both. Okay, all right, so what about our range values? On the range, we're going to start at the toes. Start at the bottom. The very bottom of our graph is this thing, which is a arrow, so it keeps going down, 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 down forever, ever. Okay, it's going to go up. It's going to skip this number, -3, but then it's going to keep going up, 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 up. There's another arrow over there on that end. Okay, so this goes forever, except for the -3. So you're already writing that? Yeah? So from -infinity to -3, and then it jumps from -3 and goes up to forever. Okay, and then you just put on your parentheses or brackets. None of these can be included, so we got all parentheses. All right, how about, well, let's do 9 real quick, and then we'll do what's down here. Okay, so this is a absolute value graph. The V-shaped graph is an absolute value. So when you're looking from left to right, does it go forever and ever from side to side? Nope. It stops at what value? That ordered pair is this ordered pair 2, 0 or 0, 2? 0, 2. So domain is which of those numbers? The 0. Okay, so the domain for this, one side has arrows, like these sides, they both go forever and ever. And even if only one of them went forever and one of them stopped, we would still have it go to negative infinity, right? Because it goes further. So we have negative infinity over here on the left, and the far right we said was 0. So then we just got to put in parentheses or brackets. Infinity always gets the parenthesis. What about that 0? I love how you're... Yes, because it is a closed circle. Yep. All right, what about our up, down? What's the bottom of our graph have? Arrow, and the top of our graph has an arrow. So this is all real numbers, but in this case, we're going to write it with the infinities, right? So negative infinity to positive infinity forever, ever. Okay, so two last things. Okay, number 10, do y'all remember from last year we talked about exponential functions and logarithmic functions? Exponents and logs. Okay, this is one of those, right? Doesn't really matter at this point which it is. But what we need to understand about this kind of curve is, look at my picture. Do you see how this edge of the line, do you see how it's not like perfectly straight up? It's still tipped out a little bit. Do you see that? But down here, do you see how this looks like it's like flat and it lays along that line? Do you see the difference in that? Okay, so on an exponential or a logarithmic, one side is going to end up hitting an asymptote that it's never ever going to cross.
Announcement. Teachers,
And
could
this
you
side's gonna
please
keep-
check your email that was sent out for Ms. Bell? Could you please send those students to the cafeteria at this time? Thank you.
All right, so see if you can write your domain for that. What's going on here? Email from Miss Bell. Oh, I changed my password. Hold on. Your password is incorrect. What? No, it's not. Ugh. I'm sure it's none of you. That was a good kids. All right, so what's happening on our left to right? Does it ever stop? No. Nope, it keeps going forever and ever? Ever and ever, all real numbers, negative infinity to positive infinity. Side to side. Arrow, arrow to arrow. Right? Arrow to arrow. I still don't have anything from Miss Bell. Oh well. What about top to bottom? Does it go forever and ever up and forever and ever down? Both. No. Does it go forever and ever up?
Yes.
Yep. But it stops down here at the bottom at what number? Wherever that line is. Negative. 1, 2, 3, 4, 5. Negative 5. Okay. So if there's a dotted line there, is it going to touch the negative 5? No. So it's going to start at negative 5, but it's going to be a parenthesis because it's just going to get really, really close, but never actually touch it. And then it goes up forever and ever to positive infinity. Okay, and again, if highlighting is your friend, you're good with that. Okay, I don't really want to talk about number 11, but I do want to talk about 12. So you see this open circle on the left here? So that value, like, is a hole, right? That's what we call it. It's a hole, okay? But do you see this dot right here? If I were to put a point right there, do you see how it sort of it has the same y value? Okay, so if I'm talking about my y values from the bottom to the top, okay, if I, like, there's a dot here, like these are all dots, right? These are all points. There are points all the way through here, okay? There's no point here, but this one, like, fills that one in, right? And then it keeps going all the way up to here. So I have a y value all the way from whatever number this is, negative whatever, all the way up to positive 2. Does that make sense? Like, there aren't any breaks in between there. Even though this is open, this other side of the line covers it up, right? But if it was like this, where there was a hole here, and then there was another hole, and then it kept going like that. Do you see the difference? Like, this is completely open, like there's no value at either of those. But if one of them is filled in, it makes up for the other one. Does that make sense? Okay, so did somebody count what number this is? It's like -7 or something, maybe? Is that -7? I think. We'll just pretend. So this goes from -7 to 2. If this is a line down here, is there going to be a dot right there? Or could there be a dot right there at the bottom? Yep. So it's going to touch the -7, and it goes all the way up, and it's closed all the way up at 2. Does that make sense? And then what about the side to side? So one of those is at -4. Is it -4? -4 and +1. So on the -4, does it touch the -4? Nope, because it's an open circle. So that side gets a parenthesis, and then it's solid all the way over to the 1, and it has a closed circle there. Yeah? Okay. All right, so the last little bit is the super easy part. So everything we've been talking about so far are just relations, right? Okay. Once we take that relation and we turn it into a function's a special kind of relation. Like, everything is a relation, but only certain things are functions, right? So in order for something to be a function, the domain has to have exactly one y value or one range value with it. Okay, so every x gets its own y, okay? Which means we cannot have x's that repeat. No x values repeat. So I can't have 3, 5 and 3, 2. Because 3 is the same x value, but it has more than one, right, y value with it, okay? But what it's going to look like in our picture is that the x's are going to repeat, right? Like, the y's are always different, or they can all be the same. Like, we don't really care what the y values are. We only care about the x values, okay? And the reason that is because a vertical line is undefined, right? So we don't want this vertical line. That's not a function, okay? If our line is tipped or slanted like this, everything's good, okay? But as soon as that line is vertical and you have a whole bunch of points along that vertical line, that's what makes it not a function, okay? So we're just looking through here. Are these all different? Yep, okay? So these are all different. So this yes is a function, okay? What about number 15? Okay, have all these numbers here. I don't care about all of the numbers. The only numbers I care about are the x's. So x, 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 x. Are those all different?
Yeah.
Yes. Cool. Okay, what about here on number 14? These are my x's. It's a little different because I have some arrows. So I have to think about what those arrows look like and what those arrows are telling me. Okay, does every x have its own y?
Yeah, but one is 2.
This one has 2. So -9 goes with -2 and -9 goes with 5. So do you see how that's a repeated x? So as soon as you have that arrow that comes off of the same x value, that makes it not a function. Okay? And again, the y values could all be the same. They don't matter. No offense, y values, we don't care about you at this point, right? Okay, so the other way that we did this on a graph is we used a vertical line, right? So if you take your pencil and you hold it vertically like this, or you were to just draw a vertical line through here, it should only touch your equation or your function at once at a time, right? So this is a function because it only touches once. Okay, if I draw a vertical line here on number 17, it's our sideways parabola. That's never a function. Same with a circle. Circle's never a function, okay, because it touches twice. So if your function sort of loops back on itself, that's what makes it not work, okay? And then this one, if I drew a vertical line here, it touches once. If I drew a vertical line here, it touches once. Here, it touches once.